So what I want to do now is actually look at some values here. So I've already got some information on my screen. We're going to do a superhero conference here in Charlotte, and these are the number of years of experience. We just made up some stuff here for our different superheroes. So Superman's been here for has 4 years of experience. Then Spider-Man 2, Wonder Woman 3, so on and so forth, right? And then I'm just gonna not do the work, but show you guys that, well, let's find the average, right? So you would jump on Desmos, you would type your data values into Desmos, just like we've done here. This is obviously old data, but you would type your data values in and you would find your mean, you would find your standard deviation. Remember to use STDEV-P. And so in this case, our mean years of experience for our average is 4.5 years, right? We'll put a years on the end here. And our standard deviation, the average spread from that mean, is about 1.7 years. Okay? So the question really is going to become now, not just what those values are, but how do they change? So for example, if we have a reunion 5 years later, Superman was at 4 years of experience. So now 5 years later, Superman has 9 years of experience. Wonder Woman was at 3, so she now has 8, so on and so forth. So the question is, how have my data values changed? How have my data values changed? What's my average years of experience now? And that might sound like a dumb question to you guys, but it's actually something that's important to think about, because if we type these values into Desmos and we asked you to find the average, if you ask, which is aka the mean, right? Then if our mean was 4.5 years of experience, now 5 years later, we're simply going to take that 4.5, right? 4.5 and add 5 to it, because everybody has 5 more years of experience. So everyone's to the mean is going to go up to 9.5, right? Because we now have 5 more years of experience. But the question is, does the standard deviation go up as well? And if you type these new numbers, 9, 7, 8, 10, 11, 12, into Desmos and you find your standard deviation, guess what? The standard deviation is still 1.7. Why did the standard deviation not change, but the mean did? The mean obviously is going to go up because our numbers are larger, right? But remember, the standard deviation is how spread out your data values are, how far away they are from the mean. Well, just because all of them went up doesn't make them any more spread out. They all went up the same amount, so they're all spread out the same amount. So your standard deviation is, in this case, is going to stay the same. So let's use that same idea, but we're gonna take it a step further. We're gonna invest some money in, we're investing some money into Snapchat. So we have a couple different folks, myself, Miss Frankie, Mr. Edwards, Miss Rabel, Mr. Switzer, Miss Kendrick, and we all invested some money into Snapchat. So here's how much we invested: 100, 50, 25. Mr. Switzer's got the money, so he invested $500. And again, we type those numbers into Desmos and we find our average amount. So our average investment was $158.33. Our standard deviation was about $162.40. Okay, so this is very basic to do because we're just using Desmos to do it. We're typing our data values in and we are finding our average, we're finding our standard deviation. But if we take our money and we, instead of adding the same amount every time, we invested in the stock market, and so our money has doubled, right? We're saying now that our money is doubling in value. So my $100 went up to $200. Miss Frankie's $50 went up to 100. Jumping to Mr. Switzer, Mr. Switzer's 500 is now 1,000. So what do we think is going to happen to our average? Our average was $158. We'll just stick with that. So our average was $158. What do you think is going to happen now that all of our money has doubled? Well, stands to reason that $158 would also just double, right? So if we double that $158, that would be now $316. 316. So just like we did when we added the same amount every single time, our um, our values are going to double, then we just double our mean as well in the same exact way. But the standard deviation, what was it? Our standard deviation was 162. Let's just stick with that, 162. So what's interesting is our standard deviation last time did not change because our data values were still spread out the same amount. But I want you to notice something. Before, between Miss Frankie and I, there was only a $50 gap, right? There was only a $50 gap. Between Miss Vrabel and Mr. Switzer, there was only a $300 gap, right? Has that gap stayed the same? Has the spread stayed the same? No, it hasn't. Now there's a $100 gap between Miss Frankie and I, not 50. And now there's a $600 gap between Mr. Switzer and Ms. Vrabel. So you can see that the gap has changed. And so when you're multiplying by something, the gap isn't going, the gap is going to change. So your standard deviation does not stay the same. It also doubles. So our standard deviation stayed the same when we were adding, but when we are doubling, our standard deviation is going to change. So my standard deviation now is about $324 spread out. So that's really key. So our takeaway here, the last thing we have to really understand is that when we are adding, our mean goes up and down by that same number, right? If we add 5 to everybody, we're going to go up by 5. If we subtract 20 from everybody, we're going to go down by 20. But no matter what we do, if we add or subtract, the standard deviation stays the same. That's not going to change. But when it comes to multiplying, if we multiply by a particular number, like we did here with Snapchat, doubling, multiplying by 2, or if we multiplied by 10, whatever it would be, we are going to multiply our mean by that same number. So if we multiply, we're going to multiply by that same number. The standard deviation, on the other hand, does not stay the same anymore. We also multiply or divide by whatever we were multiplying by. So it's really important that we see that difference between how adding changes our data versus how multiplying changes our data. Adding has that constant effect. It's going to move everybody in the same way. Multiplying, like an exponential function did in Unit 3, it didn't have that same effect on every single data point. The rate of change changed. So it's really important that we make that distinction. And that's kind of the last point of making sure we understand how our standard deviation is affected and how our mean is affected when we add and subtract versus when we multiply and divide. Hope that makes sense. Keep working hard.